Hey, this is Rolf for Sleuths, Block Ops. Here to talk to you today about what we're doing to get our secure node system implemented. So secure nodes are a big part of ZEN Cache, and let me talk to you a little bit about the purpose, how we're going to go about doing it, and then some of the specific systems that we're going to build in order to make them happen. So first off, I wanted to do a quick review of why we even have secure nodes, why we care about it. So let's go back to the purpose of ZEN Cache. One of the things that we want to do is enable private transactions for people worldwide. So this is using the shielded transactions, so people can send and receive ZEN Cache, and it doesn't record in the blockchain who sent it, who it was sent to, or how much was sent, just that a transaction happens. So that's great, we want to do those. Within those shielded transactions, we can do private communications. So we can do one-to-one private communications, and then in the future we want to be enabled doing one-to-many private communications. And when we're able to do one-to-many private communications within that memo field of the shielded transactions, we'll be able to put a URL to allow for anonymous publishing to, for example, IPFS, Interplanetary File System, or something like that. So that goes back to the purpose of it. Now, how are we going to make sure that these things stay private? Well, there's a few different ways that we can do that. And so it goes back to how ZEN Cache and how blockchain cryptocurrencies work. And it's done with transactions, and the transactions start out at a wallet. Right now, the wallets are running on a desktop, but we'll also have mobile wallets and other types of wallets in the future. That wallet sends information to a node. The nodes send it to one another. Those end up going to nodes operated by mining pool software. The mining pool software puts those transactions into a ledger, and that ledger gets wrapped up into a block that it gets appended to the blockchain. So that's how we have a blockchain system. So how are we going to make sure that this stuff stays private? Well, one of the things that we're working on is to encrypt all the communications between the wallet and node the node to node. So right now our development team is working on adding OpenSSL capability to the node software. So that means when nodes talk to each other and when wallets talk to nodes, that they'll be able to do that using SSL certificates and encrypted communication, because right now none of the communications encrypted between the different nodes. And we want to have many resilient nodes. We want to have a few thousand resilient nodes out there. And that's one of the things that is what I think one of the issues with many cryptocurrencies out there from a standpoint of resiliency. Now, Bitcoin doesn't have that problem. I think it's got 7,000 to 10,000 nodes, maybe even more, that are run by many different people all over the place. But for some of the cryptocurrencies that don't focus as much on having many resilient nodes, they have a few hundred, maybe at most 1,000, and not really sure what type of machines these systems are running on. So in order to be able to make sure that people worldwide are able to do these types of encrypted transactions and communications and anonymous publishing, we want to be able to have lots of different nodes out there that are resilient and can handle things, because if for some reason someone in a country doesn't like what their people are doing using ZEN Cache, those nodes might get attacked. So we have to, from a standpoint, make sure that those nodes are somewhat secure and resilient so that they can stay up and running. And because we want this, and this is important to us, and we have the ability to do this, we're going to pay the node operators to get what we want. And so I'll talk about that in just a minute, of how we're going to pay ZEN Cache for people to operate secure nodes that meet our standards. Okay, so I told you what the purpose of secure nodes were. One of the things I guess I want to talk about is what is not the purpose of secure nodes. The purpose of secure nodes is not to take ZEN out of circulation in order to artificially raise the price. Don't really see that there's a need to do that. And also, don't see that secure node operators are going to be the entire set of governance. So many people that come to our community in Slack and ask questions compare it to Dash master nodes. And I'm a Dash master node owner, and I think Dash has a great system. I'll contrast what they're doing and what we're doing for people that are interested in it. But what we're doing with secure nodes is entirely relevant to what we're doing for the purpose of Zen Cash. So just wanted to put that out there so that we're all on the same discussion level. So the mining reward redirection that we do, 3.5% of it goes to secure nodes, and I'll talk in a minute about how the secure nodes qualify for it and how we're going to put together a system to enable that. And so the secure node system, in brief, has to enable it, track it, verify, pay it, and then report on it, as you can imagine that we'd want such a system to do. 8.5% of the mining reward gets redirected towards governance. I'm not going to talk about that today. That we'll save that for another time. And that's one of the things that Rob Viglione is working on, and I expect he'll be talking a bit more about that. So let's review how Zen Cash was funded. So we didn't start out with a large pool of money through an initial coin offering. We didn't do a pre-mine. We're not venture capital funded. We're funded by the 12% mining reward redirection. So we're using these governance funds to pay for the Zen Cash secure node system, to pay for the implementation of governments, to pay for the other things that we need to do, like getting hardware wallets and other stuff like that. Now that we've discussed the purpose of the Zen node system and how we're going to go about funding the creation of it, let's talk briefly about what the Zen secure node requirements are, and then we'll go through the system that we're putting together to make it happen. So secure node requirements, to meet all the things that I talked about before, we want the people that are running secure nodes to be bought into Zen Cash and what we're doing. So we want them to own some Zen Cash. So 42 Zen Cash is what's required for each secure node that you want to operate. You need to have a valid SSL certificate that's used in the Zen node software. Obviously, if we're going to use SSL or TLS certificates to be able to do encryption between the nodes, you got to be running it on the node software, and it's got to be valid. Have your system be able to process shielded transactions. Now this is where it requires the system to have a little bit of computing power. So a shielded transaction, a Z transaction as it were, it takes at least 3.2 gigs of memory, and a decently powerful processor takes it about a minute to create the transaction. So instead of having a very minor bit of computing power applied to the secure node, by making the secure node have to be able to do a shielded transaction, which fits right in with what it's supposed to do anyway, then it helps meet the computing and resiliency requirement. And it's much less likely to be hit hard by a denial of service attack anyway. And in the future, we want to have secure nodes be able to operate as a distributed computing consensus. Now, going back to the purpose of Zen Cash and to be able to do all these anonymous transactions and communications and publishing, we figured that we would do the testing and rewarding of secure nodes by doing a challenge and response system. So not only are we going to say that you have to have the ability to process a shielded transaction, but if you want to participate in the secure node payment reward, then you have to actually be able to prove that you're able to do a shielded transaction. The good thing about having all the secure nodes on a regular basis do shielded transactions is it means there's a bunch of them out there happening on a regular basis, so that people that want to do shielded transactions, whether for communication through the memo field or through sending Zen Cash to each other, if any of these types of transactions, people that are monitoring the metadata of them, if they're able to, will see that there's a whole bunch of transactions like this going on all the time. And they're not able to say, oh, I see that there's some shielded transactions happening over here in this cluster of IP addresses. Let's go check out what's going on over there. Instead, there's a base level worldwide happening. The system that we need to track and reward Zen Cash secure nodes isn't just one piece of software. It's not just a piece of software that needs to be developed. It's a system of applications and servers that are going to run together to do that. It doesn't have to be a very complicated system, but it needs to be put together and operated. So I put together a high-level specification, kind of a system-level diagram and explanation of one way, the current way that we're planning on having this work, and this is to get something up and going. It's not really what we want to have long-term. Long-term, we want to have this in a distributed fashion, run by the secure nodes themselves, and things pretty much happen automatically. But right now, we can get things going and get secure nodes going by putting together a straightforward system that will put out a challenge, nodes will respond to it, we'll track those responses, and then we'll do a pay cycle on a regular basis, like every week or 2 weeks, to reward nodes for the number of valid responses that they've sent back. So we're having a discussion right now on the ZEN forum. You can go take a look at this at forum.zensystem.io. Love to see what different developers and people think about this. And we're going to contract the development for this. So we already have developers that are working on our ZEN node software that are implementing the OpenSSL, which is an important part of it. So in parallel, I want to develop the Zencash secure node tracking and payment system, and that's what we're talking about here. And I would see this as being a piece of software that's running on nodes, maybe a Python script or something like that, that checks the challenge location and provides the response, and does that on a regular basis. And for the development, we're going to pay for Zencash that we're building up in the treasury right now, and we're looking for proposals. To me, the right way to do this is to start out with a project manager that's going to take responsibility for the development and the different parts of the system. Not saying the software development project manager is going to do all the work themselves, but be responsible for coordinating between the different people that are going to be developing the different systems. And in order to do that, I expect that we're going to have more specific technical specifications written for the different elements of the Zencash secure node system. Okay, let's talk about the different elements of the secure node tracking and payment system and talk about how they work together. So there's a lot of different charts boxes on here, but let me explain as we flow through a process here. So the challenge publishing system is going to publish a challenge. Okay, so a challenge that we put in the high-level specification is that system will go find a transaction somewhere in the entire ZEN blockchain and come up with a transaction number and publish that transaction number, and the required response, part of the required response is going to be to find the first ZEN address in that transaction. So so we'll publish a challenge, and I see that we would be able to initially publish a challenge on a server, and then the nodes would be able to read it using JSON or something like that, or a web page. There's a few different ways that we can publish the challenge, first in a centralized manner, and in the future in a more distributed manner. But we're getting something up and running first. So a challenge is published, and now the secure nodes are going to be running the regular ZEN application with OpenSSL, and then the secure node application itself, which is going to be like a Python script that does a bunch of different things. So this secure node app is going to be continuously looking to the challenge publishing system for challenges to be published. When it sees one, it then takes action. So the format of it's described more completely at the forum, but the format of the challenge is, okay, here's the transaction number, here's the challenge sequence number, here's the time that it's got to be done, or we'll say, the responses all have to be in 1 hour or something like that. So then the secure node app looks through its blockchain, finds the answer, and then creates a response. And that response is going to be a couple different things that it's going to publish on its own node. And that'll be like, okay, here's my SSL certificate. This is my T address that has 42 ZEN in it. Here's the response to show you that I've done the response properly, and other things that might be necessary to show that it's a valid response. Then it publishes that, and then it takes that URL for the publishing and puts that into a shielded transaction and sends that shielded transaction to the ZEN blockchain. Okay? And part of the challenge is, hey, send it to this shielded transaction. Okay, so the challenge has happened, and then the response has happened. And the response is in the form of a shielded transaction with information in the memo field that says, okay, here's where I actually published the response, and now you got to go find it. Okay, so that's the job of the tracking system. So the tracking system, it gets what that shielded address is, or it has the ability to read that shielded address, and as those transactions, the shielded transactions with the memos on them, get published to the blockchain, the tracking system is able to read those and read the memo field, and then extract the contents from the memo field, and then go to that published URL, which at this point in time is going to be on the secure node itself. So that secure node, remember, it's got to have a valid SSL certificate, and it's got to publish the response. So the tracking system gets the shielded transaction, it reads the response, and it keeps track of them. Okay? And it can figure out where, it just gets all the responses and keeps track of them. Then we have the reporting system, and the reporting system is going to display the responses as they come in. Now you can see that I've listed these as separate systems. We may be able to put them on the same server, and then for resiliency we'll put the same copies of these servers running in multiple locations, managed by some type of DNS management program or something. So we're not just going to have one box out there running this whole thing. We want to set this secure node tracking, reporting, and payment system up in a resilient fashion as well. So the reporting system is going to display the responses as they come in, and then it's going to check them to make sure that they're valid responses. And for every challenge, it's going to list the valid responses to the challenge. And one way to refer to each of these secure nodes out there is by the T address that the secure node is staked by. There's other ways to refer to this secure node as well. So by tracking how many valid responses there are per challenge, this system is able to provide information for payment. Because we have a certain amount of the reward that is built up, so 3.5% of the overall mining reward, and that gets built up, say it's built up during the course of a week. And that mining reward is going to be spread out proportionally amongst all the valid challenges. So if we start out in a basic fashion of doing one challenge per day, and everything works out well, then all the secure nodes that make the valid daily challenge are going to get their daily reward. If the machine's down or there's a problem on one day and it only gets 6 out of 7, well then that's only going to get 6 out of the 7 days credit. Okay, so that leads me into the node payment system. So the node payment system, it takes the information from the reporting system and says, all right, we're going to be making this payment to all these different T addresses out there. And so it calculates the payment and then makes the payment. Now, when we start out, we're going to have manual review of the things that we're doing on this, just to make sure that as our system goes through, we don't have any strange things pop up, because we want this system to work well and for the people that are running the secure nodes to get rewarded appropriately. Now, we've got to have something that shows all the stuff that's going on, and we want to track how many nodes, secure nodes there are out there. So we're going to run the node information system to work to keep track of how many secure nodes there are out there, and graph that over time, and do other stuff like that. And there's other systems that we're going to need to make this run well. People want to have a report of all the different valid transactions or valid responses that they've had. And we also are going to have a good block explorer so that we can explore all the different blocks. The big picture, this is the secure node system that we're putting together. And right now, we're talking to developers, talking to software development project managers, and we really want to get this project off and running because I think this is something that's unique to ZEN Cache, the secure node system, and it's a way for other folks to get involved. But really, it's important for us to be able to do this kind of system and have it running so that we can accomplish the objectives of ZEN Cache for the private communications, private transactions, and then the anonymous publishing. So please go check out the forum post, and if you come up with other ideas or things that we're missing, or perhaps a more elegant way to do this, love to hear from you. Thanks.